Hello everyone, we are discussing about the derivative of a function. We will be learning about derivative of a function. So we have here list of derivative rules. So we have the constant rule, the constant multiple rule, the power rule, the sum and difference rule, the product rule, the quotient rule, and the chain rule. So we will be using these derivative rules in finding the derivative of the given function. So we have here 5 examples. We are going to find the derivative of each of the following. For number 1, the given is 5 of x is equal to x to the 10. So in this number, we can use the power rule. So we have here the f of x is equal to x to the 10. So the derivative of this function is simply equal to, so you can drop the exponent in front. So you have here 10x, then you reduce the exponent by 1, so you have here 10 minus 1. So that is now equal to 10x to the 9. So the derivative of the f of x is equal to x to the 10 is simply equal to 10x to the 9. Okay, that's for number 1. Okay, so for number 2, the given function is the g of x is equal to x to the exponent of 5 over 2 plus 3x plus 4. So again, the given function is g of x is equal to x to the exponent of 5 over 2 plus 3x plus 4. So in finding its derivative, so this is now equal to, again, you simply drop the exponent in front. So you have here 5 over 2 x, then you're going to reduce the exponent by 1, so 5 over 2 minus 1 plus the derivative of 3x is simply 3 plus the derivative of 4. The derivative of constant is 0. So again, this is now equal to 5 over 2 x. The exponent now, so we have here 5 over 2 minus 1. You can have it 2 over 2. So 5 minus 2, this is 3. So over 2. Then plus 3. So you need not to write the 0. So again, the derivative of the given function in number 2 is simply equal to, so the derivative of a function g of x is equal to 5 over 2 x to the exponent of 3 over 2 plus 3. Okay, so that's for number 2. Okay, for number 3, the given function is the h of x is equal to 1 over x plus 1. So in this example, you can have, or you can use the quotient rule, that is the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the square of the denominator, or simply the log d high minus high d low over the square of the denominator. So for number 3, again, the given function is h of x is equal to 1 over x plus 1. So again, in finding its derivative, so this is now equal to, again, the denominator times the derivative of the numerator, which is the derivative of a constant, that is 0, minus the numerator times the derivative of the denominator, which is the x plus 1. So the derivative is 1 all over the square of the denominator. So you have x plus 1 squared. So to simplify, that is now x plus 1 times 0 is simply 0. So minus 1 times 1 is just 1. So we have here negative 1 over, if we're going to expand the quantity x plus 1 squared, so that would be square the first term, twice the product of the first and second term, then square the last term. So we have here the denominator x squared plus 2x plus 1. So simply the derivative of the number 3, the h of x is equal to 1 over x plus 1 is simply, so you have here the derivative of the function h of x is equal to a negative 1 over the x squared plus 2x plus 1. So we are now on example number 4. The given example is the f of x is equal to 3x squared. So again, the given function is the f of x is equal to 3x squared. So in finding the derivative of f, simply equal to, so again, you have here the coefficient of 3, so you simply write the 3, then apply the power rule. So you're going to simply drop the exponent here 2, so you have here times 2x, then reduce the exponent by 1, so you have 2 minus 1, so that would be equal to 3 times 2, that would be 6x to the exponent of 2 minus 1, that would be 1. So again, that would be equal to 6x. So the derivative of the given function in number 4 is simply equal to 6x. So we are now on example number 5. Example number 5, the given function is f of x is equal to 8 minus x cubed. So that would be the derivative of f is equal to, so the derivative of a constant is just equal to 0 minus, then in the second term you may apply the power rule. So again, you simply drop the exponent in front, so you have here 3x, then reduce the exponent by 1, so you have here 3 minus 1, so that would be equal to 0 minus 3x, then you have the exponent as 3 minus 1, so you have here 2. So our derivative in number 5, so that would be equal to negative 3x squared. So again, the derivative of the function in number 5, that would be the derivative of f is equal to negative 3x squared. So we are done on the 5 examples in finding the derivative. by using the different list of the derivative rule. So again, thank you for watching and for listening as well.